Hello, this is Darren Pulsipher, Chief Solution Architect of Public Sector at Intel, and welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. On today's episode, we're going to talk about operationalizing your data pipelines. Sarah, welcome.
Hey, Darren, how are you doing?
I'm doing pretty good. Hey, we're finally finishing up this series. It's been a great series talking to you about the data-centric organization. We've had a lot of great debates, you and I, trying to figure things out. Now we're going to talk about something that's more in my wheelhouse, operationalizing things, right? This is where IT gets to step up and do something fun, right?
It definitely is. Yeah. You get into the messy part of this.
That's a good way to put it.
We talked about the data part, which is messy. Now let's talk about the actual implementation and operationalizing and talk about how messy this can be.
Yeah, the whole key to this, from my perspective, is how do we turn it from a science experiment from happening once to turning the crank? So now, hey, I've got this. I can do more models faster, or I can take a model I've already used and turn it every single day to get more information out of it. That's where we want to get to, right?
Right. We definitely want to do that. All right. So let's talk about operationalizing, and let's go back to kind of the first podcast that we did. We talked about kind of comparing an analytic system to an electrical system. And just to kind of recap on this, we think about an electrical system, as long as you have the power source, a way for the electrons and to move around, and the light bulb, you basically can set that up, walk away 6 months later and be able to flick the light on and know that it's going to work. It's an enclosed system. With an analytic system, you don't have that luxury. You don't know that you're going to be able to turn on the lights, flip a switch and be able to have the lights working, 6 months down the line, even, maybe the next day, because essentially you have to think about it. There's a lot of things that can go wrong in your data pipeline of taking your data and being able to feed it through your system to, so that you can get some insights, and that's the light. Some of the things that can happen are kind of, your data can change, the data quality, something degrades in there. And these are all the things that have to be thought of when you're, planning out your deployment. What can go wrong in the system, and what checks can you put in just to be able to say, ooh, I got a short circuit. How do I correct this?
This sounds very much like what we talk about in computer science about defensive programming. You can't be guaranteed that the input is always going to be good input, right? You have to write your code, so same thing with data. It sounds like there's a lot of variability in data that could be coming in. So you have to be able to have your data pipeline set up to handle any variation in data that you might get.
Right, precisely. And you're actually hearing a lot of different scenarios just within this whole COVID, from, going from February, where everything was kind of the norm, going into, end of March, you see a lot of these systems starting to break down because the dynamics of the patterns that were considered norm changed because of what was happening with COVID. So, not that you would ever be able to predict that COVID was coming around. There's always the black swan type events that you'll never be able to have. But it's something that you should, be thinking about in here, like what could happen. It could be a very low probability that could happen, that could break this. And how do we be able to flag that before, you get really bizarre results.
So it's important to be able to at least detect them, right?
You want to be able to detect it, or
Detect
just
some
be able.
abnormalities in your results or whatever, right? Because you can't, like you just said, you can't plan for everything, but you need to be able to at least detect when something has happened that is outside the bounds of your original analytics, right?
Right.
Gotcha.
That's correct. Right. So just think back, at our example where we were saying, how many widgets do we need to produce? We had the customer demand, we had the supply, the current supply, and then also yield loss. How stable are those over time, and what could possibly, the customer demand right there. What could happen? Could there be something where there's a PR type event that basically either exploded the demand or degraded the demand? How something like that could have a big impact on your models, that you want to be able to, hey, when is is this starting to, are these trends starting to look different from what we've had before? Because one of the things you have to realize is all what machine learning and deep learning is looking at patterns that you've seen before. If these models or machine learning models have never seen those patterns before, they're never going to work. They're going to start failing or degrading. And you're going to need to go and figure out, okay, what happened? Why is this happening? What patterns, are we now seeing that we haven't seen before? So you always have to be on that edge of
Discovery.
Of discovery.
Yeah. So this is an interesting point, because I can only be on that edge of discovery all the time if I have my data pipelines automated. Because you don't, right? You've got to be able to run them periodically and automatically, right? Without having to go, oh, I think there might be a change. Now I've got to go and hand do things. That just takes too long, right? You're going to miss the events, right? That are
Right.
changing.
Yes. Yes. So you want to, and that's the competitive advantage of having data analytics or machine learning or deep learning capabilities, is you want to be able to, with a snap of a button, be able to pull the most current data and seeing how that data is giving you some kind of insights. Are you seeing the same patterns? Or are you not seeing the same patterns? Are they predicting? What is it predicting? The more that you can do that and be able to answer the questions you want, the better you're going to have. So it's really important that you are able to streamline that. The fewer humans in that loop will enable you to move through that and get that information much quicker.
So we talked a lot about the insight, the analytics, and all that stuff. So I love how we're talking about the automation side of things. This is where your IT team really needs to sit down with your data team and talk about what can be automated, what should be automated, and not just on the data that's coming in, but also managing any changes to the model that the data scientists want to make, so that it can be easily integrated back into the workflows that are going on. And you kind of broke this down into like two different types of controls, right?
Right. So I call them the deployment short circuits, and there's two categories on that. There's the analytic system controls. So the systems that you're going to automatically, you're going to build in through your DevOps. All right. And then the other part of it is really is organizational controls. This is kind of more the people part of it. A part of it. So I'll talk about both parts on here. The analytic system controls are really about, how can you package up, the models that you've trained, and then put them in, and so that essentially you're able to answer the questions you want. easily. So you're taking a model and actually putting it in and feeding data through it as needed. But there's also some other things too that have to go around this deployed model, which is also monitoring. And you're looking at how to check for accuracy of that data. Have any of the environmental changes occurred? Is the quality of the data changed for some reason? Maybe, you're just hooked up a new machine that hasn't been calibrated properly. So now that's gonna, potentially be giving you, wrong information, and the model can't handle that. Maybe just something happened in the distribution of that data as well. So maybe as you're making widgets, some raw material came through that has a little bit of, it might be within, like specification, but the model can sense that, there's been a change in this raw material that it could cause, some changes within that, within that what the yield prediction is, or maybe it won't, predict that there's going to be a yield problem. It depends on how sensitive your model is.
So this really sounds a lot like what we run into in the software development world, where changes can adversely affect, or things that we didn't predict happen. So we actually come up with regression tests and golden data that we use over and over again to make sure that our models or our applications are working under the guidelines that we established, right? So it sounds like you need the same thing for your data analytics as well. You need to have test suites. You need to have, so that sounds very similar.
Yes, definitely. All that stuff. And that's all the stuff that I'm so glad, to hear that capabilities within, the IT department, because this is the stuff that we're really like, when I was working in this area, I was like, oh, my head would explode, because what are all these things and so forth.
Well, the good thing is you could take advantage of your IT organization. They do this every day, right? So this goes back to our great conversation when we first started. IT is a black box. There's like one guy that works in there, right? And I'm like, well, data scientist, it's just one person playing around with numbers. So what, But now we've learned, right? We need each other to really, you need IT's help to operationalize all the great work that you're doing, monitoring, automated test suite running, all those analytics system controls that you talk about. Believe it or not, there's a whole slew of tools out there that we can use already in the IT toolbox. So that's good news.
Yeah, it is. You're really not, needing to invent any new process. It's existing. You just have to figure out how to blend the processes together so that, it becomes something working. Getting the two groups together, the DevOps and the data scientists together, so that they're setting themselves up for success.
Sounds like data DevOps needs to be created.
Right.
There you definitely go. All right, let's talk about the organizational, because I think I can handle the analytics controls. My team's going to step up and help you out, right, from the IT side. What about the organizational controls?
So the organizational controls is really around trust. And if you can remember back when I talked about the organization foundation and making sure that, you're bringing in a diverse team of people, your subject matter experts, your management or your line of business, you want them to, I talked about having them in part of the process at the beginning. And a lot of that is just on the trust. They need to be able to trust that you have the right data, that, they understand kind of how these models were created, what they can do and what they can't do with this data. All right. So, when you go into deployment, you have to also make sure that, they continue to trust and they feel empowered to provide provide feedback of whatever they're seeing, because they essentially need to be able to own this as much as the data scientists are and the DevOps people, because if they don't trust it, this just becomes an academic exercise, and all this work is just going to just not be utilized.
So this comes back into our business process thing, where you have that feedback loop.
Yes.
That's what you're talking about, right? Where the users of the data are giving feedback in and providing maybe different parameters to the model and all that. You need to build that process in, it sounds like. You can't just throw it over the wall. Here's your data.
Precisely.
Okay.
And there's a and these are the subject matter experts too. So if they understand kind of the data that's going in and so forth, they can also be the ones that say, hey, there's a dynamic going on in the markets, or with our customers, or whatever, like, be cognizant of it. Maybe we need to be monitoring it. So they can help provide checks on the monitoring, it's really about giving feedback of what could be changing, how are they using it, and what could be improved. And again, this is something that isn't you're going to take this model and implement it, and then it'll be there for the next 10 years. These things need to be iterated on and improved. So, so it's really important to, one, be able to get that trust, get the alignment, and have these feedback loops on here. The other aspect too is you also want to have create a way where they can easily consume the information. So if the model says, hey, we're going to have this many, we need to make this many widgets, and they want to understand kind of like, hey, why is it so high, or why is it so low? You want them to be able to, have a dashboard that kind of tells them that information, but also be able to dig down into why something looks a little bit off. So
it can't just be a red light, green light thing. Oh, everything's green. You need to be able to drill down and find out why you're on target or off target, right? So that's what you're talking about with the dashboard.
Right.
And you don't really want the consumers of the data calling the data scientist anytime anything goes red, right?
Right. You basically want to empower them with the information that they have. And then the more that they can dig into this, it also feeds into the feedback loop. Hey, look, we see this information here doesn't seem to be reflective of what we think is really happening. Can we go investigate this? And the more that they can investigate or bring up what needs to be investigated, the more empowered your organization is going to be.
All right, let's talk a little bit about my side. Okay. I'm going to be selfish now, right? So yes, you gave me all these requirements, Sarah, tons of requirements on, hey, we need continuous integration, we need monitoring, I need to be able to test and things like that. I think one of the key things that is going to help with operationalizing from your data pipelines and things, use version control. Use GitHub. It's a great tool, or GitLab, whatever you want to do, but use a version control system. That's probably the number one thing I would suggest, because I've already seen way too many people go out there and, oh, I made a change to my model. Can you grab my file from last week from my laptop? And yeah, it's a mess, right?
The other thing too is there's one thing of having the model, but you also want to be storing the data that that created that model too. Because if for some reason, you can have the model, but if you don't have the data to understand kind of how, what the patterns, or maybe, hey, I never thought that there's this feature in here that is really important. How did that impact, how would that have changed the model? It's really important to have that for audit purposes.
Oh, that's a very good point. And believe it or not, you can store really large files into Git, really large files into Git without a problem. I made the mistake personally. I just stored links into Get on where the files were. Yeah, and guess what? The files moved. Now they're not there
I
anymore.
can't imagine
And
that ever happening.
yeah, exactly.
It happens all the time, right?
So I love checking everything in together. And there's some great techniques out there to do that. You can even do this with containers and things like that. Go out and take a look out there. Even on our podcast, we talk a little bit about dev services. Take the same concepts with dev and work it with dev data DevOps, right? I think that will be a large benefit. The other thing I can offer you is continuous integration and deployment. So using a tool like Jenkins or even GitHub Actions and things like that. So when you work on a model and you check it in, it automatically kicks off running your test against your model with your data in a test environment. And you can even generate gobs of garbage data on the fly too. We can offer that to your data scientists as well. So I think that's a good one.
Yeah, and that's another good point too. If you have this historical data, you can also plug it into your new models too to say, okay, how well does my really ancient data impact my current data? Because you really don't know if something's going to go back to what it might look like at one point, even though things have changed. So
yeah, because you don't want to abandon your legacy data, right?
Right.
Because if you do, then your models are only as good as how old your data is, right?
Right.
Which today would be, I think, would be really fascinating. Looking at data today in post-COVID, or we're not even post-COVID, we're in COVID, right?
COVID, yeah.
I think the data is going to be very different now than it was a year ago and what it will be a year from now. But I think it's all valuable data. But if I based all my models just off of what's going on this month, we're going to have a very skewed picture of the world. Oh, everyone works from home, right? Crazy things like that. In fact, a great case in point on this is in the Department of Navy. They just had a finding from their data that since COVID, 95% of their IT workers are working from home, remote work, right? Productivity's gone up 35%. One data point. From that one data point, I would say everyone's going to work from home from now on. And will I continue to get a 35% increase? Or if people come back to the office, am I going to see a 35% decrease? So one data point, although it's a great soundbite, is not necessarily sufficient. So keeping that data around is going to be important.
That is important. And, I always use this as an example. If you think about the 2008, 2009 the Great Recession, nobody ever really anticipated that the housing market would crash so much, because pretty much, it never went down that much. But there were other dynamics, all the economic models never really saw such a decline. But because of the whole, the bad loans and so forth that were all packaged, you started seeing things crumble that you never saw again. I never saw before. So, there are things that could be completely stable or have a little bit of fluctuation, but soon as they start, fluctuating a bit or really degrading, it can just totally blow your models apart. So those are other things to think about. So even stuff that seems stable and you've never looked at, or basically threw out because that's stable, that's not a problem. You want to make sure that there's some kind of confidence band around it, that if it goes outside that, then you want to be flagged about that.
So that's where monitoring, that's another thing I can bring to you, is monitoring. Right. I can actually monitor the output of your models for you automatically. And also, I also want to monitor how your models are performing in the infrastructure, right? Because I know this already because I've seen this before. sometimes your models run really fast and sometimes they take days to run. And you're like, now, why is that? Well, maybe we hit an edge condition in your data that made your model spin out of control. And we can alert you from the IT department, right, with our automated continuous integration and deployment. We can alert you when something's taking longer than outside of the norm and notify you. And then now you can actually stop something from spiraling out of control because you already know the data is outside of the bounds or whatever it is. So there's some other great things that IT can bring to the table to help your data scientists.
Right. So you really do need, sounds like you need to sit down, with your IT people and your data scientists and go, okay, here are all the variables or features that we're looking at, and then trying to figure out, okay, how do we monitor each one of those? At what point, should we have a flag? And some of this can be subjective, and some of this could just be based on what you've seen historically.
Right. Well, and ideally, I should just give you the tools that enable you to do that easily. Right. I mean, I want it to be as self-service as possible because I don't want the data scientists come into my org. There's a new area we want you to monitor. I should make that easy for you to say, hey, if this data goes outside these bounds, throw me a flag. I think that would be far better. That's why you really need an IT organization that's invested in the whole data value creation, which I think we've been missing in the industry as a whole.
Right. And then the other aspect too that we could also think about is, designs of experiments too, because some, interactions among variables or features are really important too. So you might have something that's stable, but you bring in something else, and then it either can go up or it can go down based on kind of what level of this other. So the way that you kind of, you have to think about this, and this is where the subject matter experts can come in. And if you know kind of what these potential interactions are, or if you don't, you can do a design of experiment to kind of be able to model that. And that helps kind of understand kind of what variability is expected and what could also be causing some of the variability, because these could be interactions among variables.
So what you're saying here is you need the ability to have several permutations of the same model, being able to compare and contrast. That's another great thing that IT can offer, right? If we can give you the ability to spin up and spin down these models quickly and automatically, then that would help quite a bit. Or possibly give you 10 different versions of the same model with different parameters run in it to test your design of experiments, right?
Actually, as a data scientist, I can build all that into the model so that it's one part of the model and so forth. So instead of having multiple models, you can have, it's basically features within the models or parameters within the models that can.
See, I learn something new every day.
So yeah.
Great. Sarah, this has been wonderful. It's been did we do 5 or 6 podcasts together about this? It's opened my eyes to data science and all the things that you guys need. I truly think IT can help you out.
Yeah, and I'm really excited about talking about what data scientists can do for the organization. So let's how can we take this raw material that people are just having sitting around and so forth and turn it into insights? It takes a team, and as as we've been talking about, the more we can talk about this and how to make this materialize, in a team environment, the more that we can learn from each other and do great things.
I agree. This has been great.
So,
thanks again, Sarah.
Thanks, Darren.
Thanks for listening to Embracing Digital Transformation today. If you liked our episode, go ahead and give us 5 stars on your favorite podcast or video streaming site. You can also find out more on embracingdigital.com. Until next time, keep moving forward and embrace the digital revolution.